is dependent on the behavior of our beam. So, parehas lang siyang format, no? Kanina sa atong pag-compute sa FMS. But this time, no, na kay 2 layers of steel, ang pinaka-obvious nga steel ang atong computer. So, the formula epsilon T is 0.003 times the distance, no, of the farthest steel to your compression minus C over C. Now, pag-compute mo ani, if this is greater than or equal to 0.005, so that is tension controlled, and we can use a reduction factor of 0.9. Okay? Mana itong value kung 0.005 ni, this will be our value to be used pag-determine sa design moment strength. So, manang minumultiply natin sa atong nominal moment, 0.9. Kung ano siya. No? But pag-compute natin, epsilon T natin is between 0.005 and 0.002. Okay, natin step 5B and 5C on the next slide. Actually, formula ni siya. No? Kung-compute natin si, magkakalculate kita pilang value ani. No? Nani formula. But if your epsilon T is less than 0.002, then 0.65. Compression control siya. Okay? So, sa malang step 5B, 5C, that is kung between ang atong value. Ito yun, ay formula. No? So, kung transition region with stirrup tie, which is in most cases, nakatay ang atong beam, although nanay uban nga naka-spiral, but seldom siya ginagamit na sa aton, so gitanggal ko na lang to. So, ang butang ko lang yung formula is only applicable for tie. No? So, for a transition section with stirrup tie or hook transverse reinforcement, no, the values, no, of our reduction factor varies linearly from 0.65 to 0.9. So, as you can see, kini 0.65 man yung compression control, di ba? While kini siyang 90 natin is tension. So ang value na pinaka will vary between 0.65 up to 0.9, no? As a function of epsilon T. Or nasa formula, kung pipili ka ganahan mag-compute ng epsilon T, na naman kay C, na kay D sub T, pwede po na gamiton. So, in terms of epsilon T, ito yung formula natin. So, reduction factor is equivalent to 0.65 plus, okay, epsilon T minus 0.002 times 250 over 3. No? Now, this formula is valid regarding na sa English unit, no? Or SI. So, pwede siya gamiton, valid siya. Same with this one, no? Valid gihapon, no? So, in terms of C and D, no? Valid gihapon siya for English as well as SI, no? So, valid siya. Okay? So, i-check na mo ni kung pilay palyo, no? So, once kung sa transition region lang na siya, ha? So, once you have this one, then pwede natin i-multiply sa natong nominal moment strength para ma-determine natin ang design stress. Okay? Now, what about, no? Okay, so transition region, no? Ayan, so parang sa spiral, no? So, include pa rin ako, spiral. So, this is the formula. But again, silda pa rin na ginagamit ang spiral for beams. Okay, so this one, no? Pag ang imong Fs is less than Fy. Since we cannot directly use atong formula ng atong T is equals to A as Fy, so kukumputon muna niya siya nato, no? So, since dapat ang atong formula is equals to A as Fs, so dapat kukumputon yung formula sa Fs, no? Ito yun. Compute sa Fs, the formula is 600 times D minus C all over C. Okay, actually this is coming from 0.003 times 200,000. So this is the formula. You have to verify whether your Fs is less than Fy. So pag makompute niyo mong Fs, then go to equilibrium condition, C equals to T. So the formula for C is 0.85 Fc prime AB. Walang atong T is A as Fs. And then substitute niyo mo value sa Fs being 600 D minus C over C. Yan. So ito yung equation natin. No? You have to calculate your C. Okay, so pag ang imong Fs less than Fy, ang mauuna niyo makuha dili si A, but makukuha mo muna si C by quadratic equation. Okay, everything is known. So kini kasabot ta ni sa value except for C. Ang atong ES kasabot ta, this is constant, kasabot ta ani except for C. So you have to calculate this by quadratic equation, no? So, yan. So magka-quadratic ta para makuha nato ng C, no? Once you have obtained your C, since no na ni, you can immediately calculate now your A, no? And then you have to check, no? Natay gitawag na minimum still ratio. Okay? So this is an empirical formula, no? So ang atong minimum still ratio dapat, no, is equivalent to square root of FC prime. Again, pag gumagamit tayo ng formula, your FC prime should be expressed in megapascal. Okay? Kini sa atong B of B, dapat it should be in millimeters, no? Kini silang duha dapat should be in millimeters. This one Fy also in megapascal. Okay? So that would be square root of FC prime times BW times D all over 4Fy. So anong, in case you're wondering, anong naatay W, no? Na kay BW. So this one is for the web. Okay, not all the times ang atong beam is rectangular, no? So kung rectangle, okay na, no? Kung rectangle ang imong beam, then ang imong B is equivalent to BW. But namatay sometimes natay T-beam, no? Duduhang imong B, nakay dire, nakay plans width, naka dire, width, no? So kung if you have T-beams, ang gagamiton nimo ang dire natin, ang smaller na T. That's why you have here BW. But kung rectangle, equal lang na siya, no? Or, no, 1.4 all over Fy BWD. So ibig sabihin, whichever is larger, no? So dapat ang imong ES is the larger of these two, no? So whichever is larger or whichever is greater, no? So if your ES na compute is less than ES minimum, the reinforcement is inadequate. So kung nakita niyo na ang imong beam will behave na parang wala siyang reinforcement, if that's the case. So you have to make sure ang imong AS is greater than or equal to at the minimum sa imong AS minimum. Okay. Ayan. So once you have now calculated na, okay, marag nibalik ang ako slide na. Check. Okay, yan. That's actually method 2 na to. Okay. By the way, this is method 2. Okay, so this is the procedure, no, for method 1. Okay, this is the procedure for method 1. So the following, actually there are many methods. We have the second method, which is lahi ang formula ang ginagamit natin. By the way, ito lang ini. Okay. This is method 1. Actually, this is ano na dapat. This is numbering dapat. Okay, so finally, once na-compute na natin, then next slide natin, we can compute the side of the strand, no? Ayan. So pag ganun nga ni, no? So kung if your Fs is less than Fy, then ang imong reduction factor is 0.65. Okay. That is the case when your Fs is less than Fy. So, ang imong P is 0.65. Okay, so that is method 1. No? Okay, so let's go to method 2. There are many ways in killing a dog. No? So, for method 2, lahat siya step. No? But it will produce the same result. No? Parehas ang value na niya, mag-differ lang siguro sa decimal point. Okay, so Isang step and the steel ratio. Okay, to complete the steel ratio. No? Steel ratio being the area of steel divided by D times D. Okay, that's the first step. Second step natin is calculate the balance steel ratio. Okay? So kung balance, ano ba ang balance steel ratio? Because we will be using that one later on kung compression or tension control pa. No? So the balance steel ratio is equivalent to 0.85 beta 1 times Fc prime over Fy equals to 0.003 times 0.003 plus epsilon y. So we'll compute kasi epsilon y. Again, epsilon y is equivalent to Fy all over 200,000 megapascal. Then we have to check the maximum steel ratio or max. Okay, so this is the same format, but this time we are using the allowable maximum allowable strains for beams. No? So sa beam, ang iyang ina-allow lang ang maximum usable strain. No? This is actually maximum, but this is actually the minimum. No? It's actually the minimum. No? Minimum to. Minimum. Okay. So you cannot go less than 0.004. That should be greater than 0.004. So minimum allowable strains for beams. Okay. That's rho max. Then compute the maximum transversal ratio for attention control. No? So yan, as you can see, mo na siya ang, di ba, for tension control, di ba, dapat ang atong ESE is greater than or equal to 0.005. So mo na siya ang steel ratio that will provide a tension control. No? So pag kinumpute natin ang atong kanina, steel ratio, if this is less than 0.005, no? Pag less than 0.005, since this is the maximum response ratio for tension control, dapat less than ang ato para mahimo siya nga tension control, no? So, ang imong rho ini is greater than 0.005 but less than rho max, then transition zone siya. Proceed to step 6. Pag ang imong rho is greater than rho balance, compression control, okay, refer to method steps, no? 6 to refer to method 1, mabalik ka sa method 1 katong at kanina nga method from 6 to 7. Okay, so based on this, much better si method 1 gamiton kumpara ni method 2. Si method 2 okay lang kung tension control siya actually. Okay, sa'yo na siya. Pag tension control siya, kasi sa next step natin, sa'yo lang yung formula. Calculate the design moment strength. No? Automatic dahil, nakukuha dahil mo si moment strength by using this formula. Taas-taas lang siya. Rho Fy, rho, okay. Reaction factor is equivalent to 0.9 madaya ni siya. No? Pag siya, kanang tension control, no? 0.9 madaya na. Rho F, rho P times rho times Fy, B squared. Times quantity 1 minus 0.59 rho Fy all over Fc prime. No? Or in terms of the flexural resistance factor, so kini siya nga value, aning R. Yan, ito na ang formula. But compute ko natin. By the way, atong R, ang result ani is equal if MPA gihapon ang unit ani. Okay? So, na board exam gihapon yung question is determine the flexural resistance factor. So, pag si board exam mo ingon nga, mag-question nga the flexural resistance factor ng ipangipana, gamitan na lang si method 2. But kung mingon siya, no, si board exam nga, determine the compression block, then do not use method 2 kay wala din si compression block 2 sa method 1. No? Okay, so for transition region, same gihapon, same set of formula. Pag-compute sa reduction factor. Okay, same gihapon, we have to check the minimum steel ratio. Okay, then ultimately, pag makuha natin, we can multiply that one by the reduction factor para makuha natin ang atong side strength. Okay, so let's have our first example to illustrate the methods. So a rectangular beam has a width of 300 mm and an effective depth of 437.5 mm. It is reinforced with 428 deformed bars. Okay, use FC prime of 41.47 MPa. and FY 414.7. So we are to compute the design strength, no? So atong beam una ni, no? Rectangle siya. So pasensya na lang sa drawing, no? So we have here your B, no? 300 mm. Okay, so ang iyang risk reinforcement is 4 na 28, no? Upat ka 28, no? So ang iyang effective dip is measured from the extreme fiber to the center of the bar. Kung siyang atong effective dip niya, this is 437.5 mm. So kini siya being diameter ani is 428 mm diameter bar. So FC prime is 41.47 MPa, and we have your FY nga 414.7 MPa. So ang ipapunta na design moment stretch. In other words, ipapangita sa ato ang PMN, no? So para makuha natin, dapat kuha natin si MN. At the same time, we have to determine also our P. Okay? So that would be our sample for today. So isosolve natin using method 1 and also with method 2. Okay, so ma-transfer lang ko sa SMAT. Okay, so pakihin ko lang siguro yung tarin. Okay, so this is singly for the one as singly reinforced. Analysis of singly reinforced. That will be our sample for today. So problem. Okay. No? Okay, so we're given with again, no? We're given with depth 300 mm, okay, 90, 437.5 mm. Okay, so ang atong diameter of bar, bar diameter being 28 mm. We have the strengths, no? Concrete strength, 41.47 PA, and finally we have FY now. Okay, so these are the given, no? Okay, so let's have the solution. Okay, so we'll start with method 1 na muna, no? Method 1. Okay, so let's go back to our method 1. So ano bang process sa method 1? So for method 1, diba, the first step is we have to calculate the, not to assume, diba? First step is we have to assume steel yields, no? Ano nga tong first, no? We have to assume that our steel yields, no? So ang formula ato is T is equals to AS, no? Times FY. That's the formula. So step 1 natin, we have to assume that steel yields, no? Okay, so AS is FY. So natay our AS. But ang atong AS, kinahanglan pa computed, no? Okay, since ang what's given is the 28 mm bar. So calculate mo ito sa area of bar. So this is pi over 4 times the diameter of bar. I-square natin para makuha natin ang area. Okay, so this is the area. So mas better i-ibutan ko sa mm. Then, para makuha natin ang steel area AS, that's simply, since upat ang atong 428, 4 times area of 1 bar. Ayan. Ayan. So we have now the AS. Kuha na natin si AS. Then finally, we can compute our T. So, kakapihon ko na lang. Okay, then finally, since si program kasabot na ni AS, no? Ayan. So we have the value. So, since force niya siya, di ba, tensile force, ang unit niya is in kilonewton. We have now your tension steel, no? Okay. So, may siya. So, just use, no? And calculate, no? So, after step 1, no? Okay. So, next step natin is, if you can still remember sa atong slide, you have to compute, no? The compression stress block. No? So, next step natin is compute compression stress block. And that is your A. Okay, so ang atong A, we already have the formula. A is equals to AS times FY. A divided by 0.85 times FC prime times B. Okay, and that is the formula. Okay, so since everything is given, natay AS, FY is given, no? FC prime is given, no? Our B is given, so we can immediately calculate, no? Calculate na, gawas tayo, no? So we have our A is 96.56, okay? 96.58 no? Millimeters, no? So we have sufficient information now to verify whether our assumption is correct. Okay, we have our A, then we can ultimately determine our C, and finally compute the stress, no? The strain in the steel. So next slide natin is check that the tension steel is yielding, di ba? Okay. So, or check, no? Check if steel yields, no? Yeah. So, to do that, no? Compute mo ito sana. Calculate C, no? To calculate C. Since ang atong FC prime is 41.47, no? That is between 28 MPa and 56 MPa, then ang atong gagamiton ng mga formula, no, based on this, no. Kapihan ko na lang ito. So ito yung gagamitin natin. Okay. So ito yung gagamitin natin, no. Determine. So therefore, ang atong beta 1 is equivalent to, okay, 1.05 minus 0.0071 times FC prime. Okay. So it is 1. No? Okay, so since this is ano, by the way, this is empirical, no? So dapat wala unit. Okay, so instead of doing that, no, i-substitute ko na lang value, no? Kaya wala unit dapat. So beta 1 equals to 1.05 minus 0.0071 FC prime na po being 41.47. 41.47. Okay, yan. So, 0.07556. As you can see, no, ang iyang value is between 0.85 and 0.65. Okay, so since natay beta 1, okay, so pwede ko na tanong ko na lang yun. Okay, I can calculate now my C. So, ang atong C, makukuha na natin C being, okay, so ang anak ko A kanina, divide by, so kini nga A, divide by beta 1. So, yan. So, anak ko distance, neutral axis, and then I will calculate now the next step is calculate ko sa strain, no? Calculate the strain in the steel. So, procedure lang niya. As long as you follow the procedure, no problema. So, ang formula natin kanina, epsilon S. Epsilon S is equivalent to, okay, 0.003 times, okay, we have given B minus C, no? All over C. So, yan. Calculate that. So, 0.0073. No? This is greater than 0.005. Actually, this is a tension control already. No? Greater than 0.005. But anyway, compute natin Fs. Okay, so by the way, no, epsilon S natin, modulus of elasticity for steel is 200,000 megapascal. Okay, so pa-compute natin karon sa Fs. Okay, this is epsilon S times the modulus of elasticity for steel. Oh, yan, so dako siya, no? This is, ayan, no? Yan, 1,453. Diba? So, pwede na ka din yung direct comment. Okay, use the F command. Okay, if, no? If Fs, no, is greater than, logical, greater than or equal to Fy, then, okay, Fs, no, is equal to Fy. Else, no, still less than okay. Pwede ko na or kiniya ko na lang na direct. Yes, ay. Still. Ayan. Okay, so pag type na to, whether still or nag-yield or wala, no? Based on that, okay, still yields, no? So nag-yield ang atong still, therefore, we can say that your Fs now is equals to your Fy. Okay na, so since nag-yield naman natong still, then the next step we have to accept, no? Accept the value of A, no? So, we have to dawaton kini nga value. This is already correct since ang atong still nag-yield, no? So, since we accepted a value of A, okay, so since then we can calculate now the nominal moment capacity. So, Mn, okay, sa formula natin nga AS times Fy, no? Times D minus A over 2. Ano? Compute na. Okay, so we have the nominal moment capacity, the Newton times, okay, ayan. No? So next natin is calculate design strength, no? Calculate the design moment capacity. So, para malisin kung kapsa to calculate our reduction factor. Ang atong epsilon S, epsilon S is equals to, itong epsilon S is actually equal to your epsilon T. Okay. Well, saan ba epsilon S? Okay, nabalik. Atong epsilon T is equals to your epsilon S. So, ang epsilon S, i-compute naman natin, which is equivalent to 0.003. No? So, pwede tayo magkamit ako direct, comment. Kung usapan niya siya, comment, then let's have F na code. Let's use the F command. Mas better din kung magamit yung F command. Okay. Now, if our epsilon T is greater than or equal to 0.005, then this is tension control. No? Mas better na lang i-diretso ko na lang itong formula para di ko mag-listen. No? So, tension control na siya kung greater than 0.05, but this time, ang reduction factor na lang. So, reduction factor natin is equivalent to 0.9. Else, no? So, kuya itong kwan, pwede niya siya o kanang kaya siya command. No? Or else, ako na nimo lang nga. Kuan. So, okay tayo loop command else. Pwede ka mag-loop actually. Hindi mo yung F na code na command. No? Pwede ka mag-another F na sa loop command. Okay. Else na code. No? If ang atong epsilon P, let's say, is less than 0.002, then the value of atong is 0.65, no? Or else, magamit ka itong formula natin nga. Here's the formula. Pasok ka sa na-paste. Ayan. Else, this value is equals to 0.65 plus epsilon T minus 0.002 times 250 over 10. Okay. So, change ko na lang himo ko na lang siya reduction factor na lang. Ayan. So, yan. So, natay reduction factor. So, pwede compute na lang ta. Okay. So, 0.9 siya. Okay, but for example, ato na himon nga lahang value, no? Let's say himon ko ni siya let's say epsilon T, let's say himon ko siya let's say 0.003. Compute siya ang value. So, himon ko siya nga 0.002 or 0.001 o 0.65 siya. Ayan na siya. So, mas better kung ato na may program daan para whatever changes. No? Okay, so we have now the reduction factor, tension controlled man eh. Okay, so since tension controlled siya, then we can now calculate our design moment strength. No? So, design moment strength natin is equivalent to okay, the formula for that is the reduction factor times Mn. Ayan. Okay na. Okay, so this is the answer. So the design for this beam, the capacity can carry up to a bending moment of 357.78 kilonewton meter. No? So ang atong beam nga, ang section being 300 by 437.5 nga depth, no? Tapos reinforced with 428 mm bars. No? Ang kaya talong nga moment ay niya is 357.78. No? So kung nalakay M yung 200 kilonewton per meter, kilonewton meter, then kaya siya dalawang. Okay, so that is the method 1. No? So this is how to determine the moment capacity of a beam using method 1. No? And then tension controls here. So the step would be calculate first, no, tension force, calculate the stress block, determine whether your stress block is valid. And kung valid siya, calculate the moment capacity, and determine whether tension control. No? So pag tension control siya, determine the appropriate reduction factor. So once ma-determine na, then we can now calculate our design moments. Okay, so any questions na yung pangupahan natin? But actually, you can get away with this kung hindi ka ganahan mag-program. No? Ikaw na lang mag-design ngayon, 0.007 that is between that is greater than 0.005, pwede convert sa na lang tension control. No? But if you want to automate things, gusto mo automatic na lang, no? Then we can have the programming. No? Wait, may programming gamay. No? A little bit of programming. So anyway, you're not really stranger to programming since naman may subject na programming, di ba? So at least use that little knowledge, no, para automate ang atong calculation. No? So kay in actual, daghang tag-design nga beam, di lang kayo sa kabuok. No? So para at least may iba na ng atong effort. So we have to automate certain things. Yeah. Okay, so any questions regarding sa method 1? Is there any confusion there sa pag-determine sa method 1? Na ay confusion gamay? Okay, so I think sa iyo naman kay what you have to do is i-follow lang ning ako slide. So while nag-solve ko ani, I am constantly referring to the procedure. No? Nasusunod ko sa procedure. No? So as long as you are following the procedure, you can immediately, can easily determine the moment capacity. No? And that's why design subject is easier than college algebra. No? Daghang makapasa sa design kumpara sa college algebra. Okay, college algebra waray process. No? Dapat magaling ka talaga mong susolve. In design, as long as you are familiar with the procedure, kaya ra. Okay, so this is method 1. Then we are to solve this one using method 2. Solve natin using method. Okay, so the same ko muna ni, and we'll call this one as method 1. Okay, so save ko siya as method 1, and save as ko for another method. Save as ko siya as method 2. So, i-delete ko na lang everything. I-delete ko para sa method 2. Okay. So, method 2 na ta. Let's compare na later on kung parehas bang answer niya. So, for method 2, let's go to method 2. Okay. Method 2, we will start with the calculation of the steel ratio. No? So for method 2, ang first step is calculate steel ratio. Okay, so ang steel ratio, the formula is rho equals to AS over AS times B. I-delete ko man noon ang AS, no? Anyway, compute pa ko balik ngayon, dali raman na. No? I-delete ko ang AS, supposed to be, wala ko dapat i-delete. So again, let's go back. Compute kita sa area of bar. And Itong AS 4 times area bar. So, delete ko nung okay. So, this time, para makuha ang ratio, kakapiyon ko na lang. Usually, gagmay ni siya nga number, no? So, if you are to use the method, so make sure nga, as much as possible, less ang atong pag-round off, no? We can maintain at least 3 decimal place siguro. Okay, kung manual calculation. Okay, resulta ni gagmay ni siya nga number. Okay, so kasi 0.0188. So in my case, no, the program is maintaining 4 decimal places. So nagagmay nga number, mga 0.00 something, no, it's advisable nga you have to use greater number of decimal points. Kung gagmay nga number, okay, it will greatly affect the solution, the answer. But kung gagmay nga number, mga 1,000.1, the decimal don't matter. No? But this one, since mga decimal daan, that what we have to consider talaga greater number of decimal points. No? Okay, so we have calculated the still ratio. Okay, we are going to compare that one later on kung tension controlled ba siya or dili, no? By comparing that with the value. No? So since we are to compare lang naman whether tension controlled or not, no? So let's calculate na lang So calculate na lang kita the maximum reinforcement for tension control. Yung compare natin, no? So calculate the maximum reinforcement for tension control. Okay, lang ka. And the formula for that is this one. Okay, ito yung formula. Since ang atong target area is whether to verify this one is tension controlled or delay, no? Kada na ito computed, no? So, okay, 0.005 equals to, okay, 0.85 times beta 1 times FC prime divided by Fy. Okay, times 0.003 divided by 0.003 plus 0.005. But again, calculate po kita. Let's calculate pa So, gamitin ko na siguro information kanina sa beta 1. I-open ko na lang itong method 1 ko. So, calculate ko na lang yung beta 1 information. Okay, same raman gapon yung beta 1. So, to calculate this one. And copy. So, let's determine this one. Okay, so compare natin. So, para ma-consider siya ng tension control, dapat meaning of value should not exceed the maximum value. No? So, since ang atong rho is less than the maximum still ratio for a tension control, no? Then our section is tension control. No? So, wait naman po. So, use the F command. So, if pwede na lang siguro tension control automatic na lang. Kaya klaro man lang tayo ng this is tension control. No? So, since pwede kami na lang nga, since ang atong rho, no? Since our still ratio, since rho is less than, no? Rho 0.005, okay, the section is tension control. So, pag tension control siya, then ang atong reduction factor is equivalent to 0.005. This is 0.9. No? 0.9. Okay. Ayan, so ang next step nato is to verify whether the section is tension controlled or delay. So next step natin is compute the design moment strength. No? So since tension control siya, we can immediately calculate the design moment strength. No? Ayan. So this is effective. Method 2 is effective if tension control siya. No? So we can calculate tayo. Calculate the design moment strength. So unahan ko sa natong nominal moment na lang muna. Pwede design moment strength na tayo. No? Design moment strength. Diretso na. Pila lang ka step. No? So, PMN is equivalent to, okay, P, based sa formula na ito, that would be P times rho, which is kinumpute na natin, rho times Fy times D times D squared, no? Multiplied natin by 1 minus 0.59 times rho times Fy, then divide by natin by divided by FC. Ayan. So, you can calculate now the moment strength. No? Ayan. So, automatic na. Okay, so this is 357. Okay, 7. Okay, so 57.6514. No? So, mali atong method 2. So, take na ito. 357. Okay, 357.6514. No? I-open natin kanina natin nga method 1. 357 gihapon, but 78. So again, nagmatter lang siya sa decimal point. No? So but ang value natin is 357. 357 kilonewton meter. So kanina 657, ang method 178. But anyway, no, it doesn't matter. No? Kung nakay kwarta na 357 pesos, ang pinakasintabo nga difference sa ani nila, ilang difference, 0.78 of 0.57, dili na mo matter. No? So we're talking about hundreds, no? Ang point something is no longer significant. No? So kung nakay 357, bisag pa 1 uni mo ang 0.78, no? It is not significant. No? Bisag pa yun, nakay kwarta ka 357, pwede rin mo yata ang 70 pesos. No? Hindi ka talaga maapektuhan. So as you can see, the answer is similar. No? Decimal siya naman. Sa decimal lang siya maglahi, no? Because of the probably the round in the formula, derivation sa formula, some of those are nararound off. No? But anyway, 357.78 o 357.65 nga ito, 65, no? 0.78 o minus 0.65, kailangan na kasintabo, no? Kung parta na siya, disintamos, no? 0.13, mga disintamos na. So, kung nakita kwarta nga 357, mangita kapag diferensya nga disintamos, no? Even 5 centavos, di ka na mangita. So, that is the logic here. We expect the same answer. Parehas siya. Decimal lang siya maglalis. Okay, so that is how you determine method 1, the moment capacity if your steel yields. No? So, method 1, method 2. No? Steel yields pa lang na. But what about kung wala mag-yield ang atong steel? Diba? So, the calculation is simple kung ang atong steel nag-yield. If your Fs is equivalent to Fy. No? And much better kung tension control, kung ang imong reduction factor is automatic equivalent to 0.9. Okay, less ang atong pag-compute. Kung hindi siya, no, tension hindi siya yielding atong steel, no, then we have to resort to quadratic equation pa. No? Medyo complicated ang pag-solve. So let's go to the next problem natin. So any questions sa problem 1? Okay, so any questions sa problem 1? Okay, so we will go to problem number 2. So problem number 2 natin, again, present. So problem 2. Okay, so a rectangular beam has a width of 250 mm and a total depth of 450 mm. It is reinforced with a total steel area of 1,875 square meters, placed at an effective depth of 375 millimeters. Okay. So use FC prime 27.6 and FY 414.7 MPa. So muna siya nga itong beam. Again, pagtiisan, pagtyaga na natin ang drawing ko. Okay, so this is our beam. So we are given with the width. This is 250 millimeters. We're not given with the number of bars, but instead we are given with the total steel area. So pag representahan na, pwede na usarang kabar na lang. Let's represent that one as 1 bar, maning atong AS, which is 1875 mm squared. Then, assume na lang ka na 1 layer siya. Then we have your D being 375 millimeters. So that is that. Okay, then we are given with FC prime 27.6 MPa and FY 414.7 MPa. So, ang question natin ito, actually this is the typical board exam questions, Actually, this is actually board exam ni siya nga question nga kung i-copy sa reviewer. Board exam ni siya. I don't know kung saan nga year, but morning problem dito. It may not be the exact numbers, probably sa actual 300 mm siya, but hindi mo lang 250 mm probably for current issues. But the problem is very similar, So as you can see sa board exam, situational ang problems, So for one situation, there are 3 corresponding questions. Labi na karon kay 100 items, So 100 items na siya, probably mga 30 plus, 33 items na siya. 33 situations, for every questions na siya ay 3 corresponding. It depends on naiuban nga duha lang, naiuban nga tulo. As long as the total will be 100. So for a typical nga situation, for every situation na ay 3 corresponding questions. So pag makuha na mo sa situation, automatic you are sure with 3 answers. So for this situation, first, like I said kanina, common niya sa board exam is you are asked to determine the depth of the compression stress blocking. Kasi pinaka-calculate lang sa imo ang atong A. Okay? The next question is determine the moment capacity reduction factor. Kasi ang pinapa-compute lang sa imo ang P. Okay, then finally, the last question is design moment strength. Pinapa-compute na nimo ang P times Mn. Okay, so once makuha nimo, automatic tulog ka question dahil ng imong answer. So you can pass the board exam actually. It's not really that difficult. The revision sa board exam as long as you are prepared. Mga question na to is actually tayo lang answeran if you are prepared. So but kung niya to ka nga, wag ka kakaibaw kung saan compression block, kasabot ka nga A, but makakaibaw sa pangalan di ay usually estudyante nahuhulog siya kay wala kaila sa pangalan sa simple. Ang nauna lang si A, but makasabot na si A pala si depth of compression block. Pwede man namin mo ng board exam nga, determine A. Pwede namin mo nga, determine A, determine P, determine PMN. Ang question na ang pangalan. So, determine the depth of the compression block. So, even though ato mga estudyante kayo pa mag-compute A, but since ang question kay determine the depth of compression block, wala naka-answer. May muna sila nga, sir, wala man to nato na-discuss katong kuwan. Waman make up ko na to. Ano ka sabot o say wala man talaga touch of dip of compression block. Okay? Because they are not paying attention sa term, no? Ang i-remember lang nila ang simple A, ang P, ang P. Ito yung na ko nga A ramang good na ang sinusolve. Ako, sayang tayo. May bawa sila ba? Since wala sila kaila sa pangalan, wala nag-solve. So it's very important nga. Dili lang ang mga symbol ang atong dili lang ang formula ang imo remember. Make sure nga nakasabot ka kung saan na siya. So for example, A, make sure talaga nga si deep of compression block na siya. Ang atong P, that is the reduction factor. Ang atong PMN, that is the sign moment strength. Kaya tingali ko ng problem nga nominal lang. Nominal, ito say wala di-multiply o reduction factor. MN ra na. Pag may problem nga, determine the dominant MN lang. Kaya pag-compute sa PMN. Otherwise, wrong na siya. Okay, so you have to pay attention to the definitions. No? Dito lang kay formula nga ito. Both the concept, the definition, as well as the formula. Okay, marang naitabo sa una. Kaya ba mag-compute sa A, pero kaila sa deep of compression block. Wala ka answer. Sayang kayo. Okay, so yan. So, matransfer ito sa SMAT. No? Okay, so alam ko pinanadaran na lang. Nakasave na ni. Hindi na lang ta. Worksheet, no? So, let's say, magyapon yung analysis. So, this is also analysis. Example, so makatihan pa na rin. Tingnan lang natin. Okay, so let's input na lang the given since wala kaila si program unless you have to provide the given. So we have the base being 250 mm. So it's very important also you know how to identify what are given. So you are given with the dip of the read, and of course the total dip. Now, take note na. By the way, ang ihatag pala is total dip. Total dip. Okay, so sa total dip na patay effective dip pala. So ang atong total dip is not really important here. So ang gagamitan natin si effective dip. So D is 375 mm. We have your AS. So si AS, di na ito mag-compute. It's already given. So AS is 1875 mm squared. Natag na si AS. Unlike kanina nga we're given with the diameter of bar. So para makuha si AS, mag-compute pa kita o area sa 1 bar, then multiply to the number of bars, then we can determine your AS. Okay, so what are given? Ano pa? So the FC prime being 27.6. Finally, FY nga 414.7. Okay. Now, ang method natin, nagagamiton, whether we are to use method 1 or method 2, will depend on the question. So, ang first question is determine the depth of compression block. No? So, kung saan gamitin natin, sa method 1 ba or sa method 2? Sa method 1, appeal sa step ang pag-determine sa depth of compression block. While sa method 2, wala nga ito. No? Wala nga ito yung calculation sa depth of compression block. Instead, ang kinakalculate nito ang seal ratio. No? Pino-compare sa maximum seal ratio. So, dili nagsosolve ni compression block si method 2. So, because ang atong problem karon nagre-require ni compression block, you have to solve the problem using method 1. Okay? Ano kung kita using method 1? So, again, sa method 1, natisarili nga kumpituhon mo ang step, no? Sa board exam, dili kinanglan nga i-kumpituhon imong step 1. Kato lang steps nga will provide answer sa question. Ang target first is the depth of the compression block. So, since kinanglaton ma-determine sa compression block, we need to steel yields for ang ating Fs is equivalent to Fy. So, kilonewton. Next, no, based on this assumption, kakalculate ko ang calculate the depth stress block, no. Okay, so to do that, natin formula A equals to AS times Fy, no? Divided by 25 times FC prime times B. Okay. Mani atong stress block, but again, dili ka dahil pwede nga ang answer na ko sa first question is 132.57. Tanaw ka dahil ka sa choices. Uy, na nga to si 132. Shade time ka, no? Be careful kay tingali ang atong steel wala nang yield, no? So you have to verify anay. Do not readily accept dahil nga atong A. Diba kay nasa choices kay probably nakagod na, no? Na-examiner nga nag-anticipate sa estudyante ko. Puputang ko ni siyang answer, no? Dito para wala shadingan sa estudyante, no? Pag-complete mo 132, tanaw mo sa choice, oy, letter A pagod. Shade dahil ka dito. Be careful nga, you have to verify whether this is acceptable value or not. No? You have to verify whether your assumption is correct. No? So verify assumption muna. So the next step is you have to verify the assumption whether ang atong steel ba nag-yield or wala. No? By calculating again your S. No? So, mabalik niya akong dito sa step 1 na ito. No? Sa atong method 1, step, isa itong step. That is step 3. No? Check that the tension steel is yielding. So, by calculating C. But before you calculate C, magkakalculate ko na sa beta 1. No? So, ang atong beta 1, based sa atong FC prime, no? Ang atong FC prime is 27.6. No? And based sa atong slide terrain, no? Pag ang atong FC prime is less than 28 in PA, our beta 1 is 0.85. No? So, since less than 28 in PA, 27.6 lang, is equivalent to 0.85. Okay, so calculate sa C, small c, no? Ang atong A is A divided by beta 1. Then calculate the 0.26 or 6 mm. Then let's calculate our epsilon S. No? Ang next slide na ito. Calculate tayo. No? Epsilon S is equals to 0.03 times A minus C all over C. Yeah. Then finally, let's calculate our Fs. Okay, again, taking note that ang atong modulus of elasticity is actually equivalent to 200,000 megapascal or pwede po 200,000 gigapascal para dili kadaghan gi-input. No? Convert lang na ito, 200 megapascal o 200 gigapascal, parehas na. So let's calculate now. No? Ayan. No? Calculate ta, pila ba ni? 842. Saman. Compare that to your Fy. This is way greater than your Fy, di ba? 842 is greater than 414, therefore steel yields. No? So, pwede pa rin magkaroon. Pag-comment na lang ta. Use the F command. No? F. Okay. If your Fs is greater than or equal to Fy, then steel yields. No? Steel yields. Assumption is correct. still does not yield. Then assumption is wrong. Okay. So, unsa man, no? Based on this, syempre, still yields yan. So, since greater than ang atong Fs sa atong Fy, then assumption is correct, then we can accept A. No? Therefore, we can accept. No? So, accept naton ang A. So, accept naton nga ang value sa atong A is equivalent to. Okay, so accept na ni. Sakto na ni value, no? This is already correct, no? So pwede na ni mo siya shadingan dito, no? Pwede na, no? This is the depth of compression block. But kung wrong ang imong assumption, magko-compute ka pa for another A, no? Katong task ka process, magka-quadratic fusions ka, kaya mauna kung makuha dito si C, dito si A. No? But since this is already, assumption is correct, then this is the answer. No? So, naka-answer sa first question, yes, check na po. So, ang next step na lang mo is that determine the design moment capacity reduction factor. So, para ma-check natin whether tension control, compression control ba siya or ano, then you have to calculate the net tensile strain. No? Calculate the net tensile strain. But again, since wala nag-mention ang ato deriyan, no? Wala nag-mention ang atong din kung 2 layers ba siya or 1 layer, no? In fact, ang gihatang is the still area lang. So, if that's the case, no, it is safe to assume that we have a single layer bar. Usa lang ka bar ang atong layer. If that's the case, then, aros kanina sa akong resolve, ang atong epsilon s, no, is equivalent to your epsilon t. No? Okay? So, because for single layer bar, no, then ang atong epsilon t, no? Is equivalent to, okay, but we have a problem here now. No? So, kung ang atong epsilon t, no, is actually less than 0.5, no? Less than 0.005 and greater than 0.002. Diba? So, this means to say nga na nata sa transition region. No? Okay, we are in the transition region. So, therefore, no, para sa transition region, ang atong formula, no, ito yung formula natin. No? Okay, ito. No? So, for transition region, this is the formula. No? Pakihon ko na lang yun. So, this is the formula for transition region. No? So, reduction factor in transition region. Actually, kayo na, may formula pa ako nga. No? Anyway, pwede ka pa nila magamit. So, manual na lang ta. So, for transition region, ito yung formula natin. No? So, since alam na natin, no? And this is the formula. No? E equals to 0.65 plus epsilon t minus 0.002 times 250 all over 3. Ayan, yung value. Okay, so as you can see, the value again is between 0.9 and 0.65. Ayan, 0.E344 for transition region. So yun, this is actually the answer na, no? This is the answer sa imong ikaduha nga question. Ayan. So, mga answer diri. Bisa determine the design moment, the moment capacity reduction factor. So, this is your answer na. Ayan. No, so, doon na yung answeran. No? Compression block and then your reduction factor. So, the next step natin, so yun na. Muna yung atong last test design, moment strength. So, yun na tayo. So, yung mo lang calculate ang design moment strength. You have to multiply lang your MN by the reduction factor, which is complete naman natin. No? So, reduction factor times your MN will give you the design moment strength. No? Okay, so you have now the answer. Yan, no? So, okay na. So, kung board exam pa ni humad ka na sa usap question mo. So, determine ka sa compression block, pagpili mo ang reduction factor, then you have the design moment strength. No? Kuman, dayon ang usa ka problem. Okay, so mani mga typical questions sa board exam. So, based on this, kayo mo ka na okay raman din. Kapasa raman ko di ay as long as you have the proper preparation. Yung uban estudyante mag-serious na sila after graduation. No? So, the problem with EBSU students na nung we have medyo dili kayo may ato performance sa board exam because most of the students will be serious after graduation. During the review na sila nagiging serious. During sa college days, dili kayo seryoso. Okay? So, you have to be very serious if you want to be able to pass the board exam. So, kung nato pa mo mag-serious sa review, it's already too late. No? Too late na siya for your preparation. Kasi bago tara ng concept sa inyo, although niyagi na ta, but you're not paying attention. So, muna katong sa review, nagka-cramming na. Whereas kung at this moment, you're already serious in your studies, pag-abot nyo sa review, gamay na lang ang inyong kinanglan mabawalan. Okay, not all topics will be discussed because of the limited natin. For example, today, online lang atong klase. So, not all topics will be discussed. So, katong wala na na-discuss mo itong iyong focusan during your review. And it's easy to understand once na nakay prior knowledge. No? So, dali siya sabson sa review kung karon naintindihan niyo ang concept. So, actually, una nila ang mga exam sa board exam. Wrong na siya ang idea nga lisod kayo si board exam. Okay? So, yun lang. Hindi mo kinanglan magpinilaw during sa consulting, during review, nagpipilaw-pilaw. Paniguro, no? But if you prepare during your student days, no? Dali lang siya sabto na. Dali lang kayo ng mga questions sa board exam. You can easily pass the board exam. So siguro nga lang kung ganahan ka mag-top notch share din, siguro mo nakatime diyan na magpipilaw-pilaw ka. But for ano lang, if you want to pass lang your goal, your aim is just to pass the board exam, I think you don't need nga during sa review, magwalay tulog-tulog. No? As long as in your college days, you are already being serious in your study. As you can see, hindi man lisod na problem. If you are guided actually by the procedure. Lisod pa si algebra ani, lisod pa si differential equation, compare ka sa mga homogeneous equation. That is difficult compared to this one. But in most cases, mas daghang nahag kung sa design, sa structural kumpara sa mathematics. Pero masayon lang ang tao. Okay, so this is yun. Typical board exam problem na to be answered. Okay, so diretso ako dugay lang because I have to explain the concept. Kung ikaw na susolvani, I think mga 5 minutes is enough. 3 minutes lang siguro kung pas-pas ka. Okay. So, yan. Let's say this is problem to siguro. So, any question? This one, maraming nga problem ay pangutana. So, kung wala, we'll go to the last example natin. So, let's go to the last example. So, last problem natin, we have so we have problem 3. So, for our last problem, okay, we have rectangular beam has a width of 300 mm and a total width of 410 mm. So the beam is reinforced for tension with steel array of 3,690 mm squared. No? So using FC prime of 27.1 MPa and steel area of 414.7 MPa, so parehas. Compute the actual tensile stress in the reinforcing bars. The actual tensile stress ko in the reinforcing bars. So say, you have to calculate Fs. Okay? Your Fs, pinapacalculate na rin. Then calculate the total compressive force acting on the section, capital C, and then with assign moment strength, capacity of the beam. So, ano siya. So, yan. So, again, pagtsagaan natin ang drawing. So, this is your beam. Okay, so the width is being 300 mm. So this is 300 mm. Again, we're not given with the rebar, but ang hinatag lang sa aton is the steel area lang. No? So i-assume na lang po natin na single layer lang siya. We're given with ES natin nga 3690. Okay, then total depth of, so we're given with a total depth. So kung total depth siya, okay, so total depth, this is actually very MB, but ang H na siya. 410 millimeters. Okay, so FC prime, 27.1 MPa. Then, ang atong FY is... Okay, so again, pinapakita na rin the actual, no? So in other words, pinapakompute sa imo ang FS. Compressive force, capital C, and then moment strength, no? E. M. No? So again, this is also a typical board exam problem. Okay. So again, the method will be dictated kung ano ba ang gipangita sa problem. So we are asked to determine your FS. So between method 1 and method 2, no? So sa method 1 gapon ang muhatag pag-compute what is your FS, di ba? Ang FS natin is given by 600 P minus C all over C. No? That is method 1. So si method 1 nato gamiton. Ang sig hapon is actually equivalent to 0.85 FC prime A times B. No? So again, si method 1 pa rin. No? Si inisig method 2, method 1, method 2, but along the way, kinalaman mo i-compute ni, so therefore, why not use na lang si method 1? So let's say, let's be using method 1. So ang kini siya, ang first natin, kini-compute natin, and next C. Kasapot naman ang CMN, PMN, no? It's equivalent to, narito ka formula, pwede mo gamit ang ASFY, D minus A over 2, no? Or pwede po tag another formula which is katong PFC prime AB times B minus B over 2. Pwede kapon. Okay, so let's go now to our estimate. So the same ko lang ni. Then, open ko another, or let's say, file, worksheet. So this is sample 3 na. Okay, so for the problem, copy-on ko na ito. Okay, so let's say first question A. And that's the problem. So again, let us input. Input ang ating mga input. we have B 300. Start gihapon from the beginning. So ang solution, we start gihapon by assumption gihapon. By assuming gihapon yung steel yields. No? So assume gihapon na. Assume steel yields. Okay, kita sa atong T. No? Or let's calculate A. So A is equals to AS. Okay, so napatay, you know, A is AS times FY. Okay. Divided by 0.85 times SC prime times B. Okay. Calculate kita, no? Your A. We have your A as, we have your FY, and FC prime, then we have your B. Oh, FC prime. Okay. Okay, so we have your A. And then we are going to use the value of A to determine sa atong FS. No? So, ang atong C is actually, no, is equivalent to A all over beta 1. No? But since ang atong beta 1, ang atong FC prime is less than 28 MPa, no? So according sa atong process, no, kung less than 28 MPa, then beta 1 is equivalent to 0.85. So from here, kung ito pag-calculate natin si C, no? Okay, so C, and so since we have now your C, we need to calculate, no? We have to verify the assumption. No? So verify assumption. So verify if still yields. Verify natin whether nag-yield ba si steel o wala. No? By calculating katong formula natin nga, by calculating the epsilon S. No? Okay, so epsilon S, based sa itong formula. Okay, it's 0.003 times T minus C all over C. Now we have a slight problem here because what is given is H instead of D. No? So ang gihatag sa ato D. No? Instead we are given with the overall depth. No? Okay. Now kung the problem here also is si problem hindi naman siya nagbigay ng actual receipt configuration rather than we're given lang with an AS na 3690. So if that's the case, we have no choice but to assume a single layer gihapon siya. No? So since wala, but kung gihatag siya, then kung 2 layers, then 2 layers, but kung 1 layer, 1 layer. But wala nagiging si problem, no? Na 2 layers po siya or 1 layer. So we have to assume na 1 layer na lang ta. So since wala tayong magagawa, okay, ang gihatag area of steel lang. Wala given kung 2 layers, 1 layer. Pag wala nang problem, assume na lang taka 1 layer. No? Okay? So, for single layer, natin formula for single layer. So, for single layer, ang atong effective dip is actually, we have an approximate formula for effective dip. Take note, this is only approximate. But if you have the actual talaga, ang actual formula is D equals, kung actual ta, that would be D is equals to H minus diameter sa stirrup. Usually 10 mm na siya. 10 mm minus po sa 1/2 sa atong 1/2 sa diameter of para. It should be the and then minus yapon sa cover na 40 mm. That should be the exact formula. But since wala tayo diameter of bar, we're not really sure yapon kung ano ba atong stirrup. There is an approximate formula for that, which is generally accepted. So for approximate formula, that would be your overall depth minus 65 mm for single layer. Kung double layer, H minus 90 mm, no? So kung double layer siya, 19 siya na rin. Okay? But kung single layer, 65 mm siya. What about yung mga 3 layers? Murag, dili na siya advisable kung 3 layers. Pwede ka siya 3 layers ang atong bar, but it's no longer advisable. No? Marag, dili na siya, it's not good. No? It's not a good practice ng imong rebar is 3 layers. No? Ang advisable is 2 layers lang atong bar. No? In this case, since we have not enough information, so we will assume nga ang atong bar is 1 layer. So we are given with the total depth minus 65 mm. That would be the effective depth. So magbuhat lang tani kung wala ba ihatag nga information. Okay, so okay. So we have now the effective depth. Since we have the effective depth, no, we have your C. Okay, we can calculate our. Okay, so compute na natin ito. Okay, so 0.001. Ano yung 0.001? Anyway. So from that, let's calculate Fs, no, that given to epsilon S times E sub S. No? Take note again, ang atong kita ko lang din. No? So for steel, palaging 200,000 ito. 200,000 megapascal. So always, for 200,000 gigapascal, parehas na. So calculate kita, Fs. No? This is the actual stress. No? This is the first question. No? Pila siya. Supposed to be, this is the actual stress. No? Our stress is 194.58 megapascal based on our calculation. But i-compare niyo mo sa atong Fy. Natong Fy. Kanina, Fy nato. Compare nato, ano? Okay, so ang atong Fy is 414.758. So, before mag-yield ang atong steel, dapat maabot niya kining 414.758. However, in this case, based on our calculation, initial calculation, if we assume that our steel yields, no, based on the initial value of our A, no, so ang atong assumption, i-assume nato ang atong steel na yield, therefore dapat ang atong Fs should be greater than Fy. But in this case, no, ang atong Fs is less than 414.7 MPa. Therefore, our assumption is wrong. Okay? So this is way below 414.7. Therefore, steel does not yield. So our assumption is wrong. No? It's less than. Okay? So therefore, steel does not yield. No? Wala nag-yield ang atong steel. Assumption is wrong. So if that is the case, no, do not accept Fs. No? So, dili ta mo dawat ani nga value. This is not the correct value. Tingali pag compute nimo 194.5. Mo na diyang imong answer sa actual tensile stress. No? Pag verify na nimo less than F5, then this is not the correct value. Okay? Dili nimo ang value. So you will not use this one para answer direct. Hindi na mao. Instead, you have to calculate this value. No? Using now the process kung ang atong steel does not yield, which is mo nga step direct. Which is ang nadaling nga step. Direct. This one. Okay, that's one. No? When your Fs is less than Fy. Okay? This will be the process, no? We have to calculate, no? So, Fs less than Fy na. No? 294 lang versus 414. So, instead of computing A, ang atong unahon is ini, yung formula, no? We have to calculate C before we can calculate our A, no? So, compute na natin siya, no? So, to do that, Kakalculate mo tag still, no? Calculate C. 0.85 times FC prime. So, ang atong A, pupulihan natin og C. No? Atong A is beta 1 times C. So, 0.85 FC prime times A, that would be equivalent 0.85 FC prime times beta 1 times C. Okay? Multiply yapon by B. Is equivalent to okay. Let's say na lang, okay, magpa-type muna ako sa equation na lang para ano, it's equivalent to 0.85 times FC. Usually, ang ato equation, yung manani, no? A times B. No? Ano siya dapat, no? 0.85 FC prime A times B is equivalent to AS times FS. No? Then, pupulihan natin since ang atong A is equivalent to beta 1 times C. Then, ang atong ano, then ang atong Fs is this one. Atong Fs is given by the formula aning 600 times D minus C. No? Times, actually, D minus C all over C. Yung formula. So, isusubstitute natin din. No? So, this becomes now 0.5 times FC prime times ang atong A being ano, beta 1. So, algebraic multiplication ng beta 1 times C times B. A is equals to, okay, AS times, okay, 600 times D minus C all over C. So magka-calculate kita, no? This is pwede siya gamitan of quadratic equation, but in this case, no, pupugitan natin. Okay, so I'm solving C directly na lang, no? C equals to, okay, solve 0.85, but take note, ang weakness sa aning formula is if you are going to use the software and then automatic mag-solve, dapat wala yung unit, no? So FC prime being, katong sa FC prime na natin is 27.1. So FC prime, 27.1 times 0.85 times C. Okay. Times bilang akong B being 300 ml. No? Okay, then equals, okay, ang akong minus C, then all over C. Okay, so, ayan. So, anong sinusolve ko? We'll tell the program, anong sinusolve? C. Okay. Ayan. So, from that, I can solve C. So, C is equals to, ayan. Again, I have two roots here. Dalawa yung C ko. No? I have a negative value kay quadratic equation siya. Kung compute mo, this is can be performed using quadratic equation. So for the quadratic equation, we have two roots. No? Usually one negative and positive value. Okay, so since again, we are dealing with real world structures, no? Real. So wala yung negative nga dimension. Instead, we'll be using katong positive value. Therefore, our C is 218.424. No? So, ang atong C karon, butahan ko ng unit, C equals to 218.424. Ayan. E kung butahan mo niya yun, hindi siya ka makasolve. No? But kung ima-manual niya mo, okay ra, manual. Quadratic equation siya. No? Quadratic ni mo niya. Kung manual, use quadratic equation. But in this case, I'm using program, pwede na i-diretso. Okay, so I have now my C. So therefore, I can calculate or I can compute now. Pwede ako compute aning akong Fs. No? So, pwede compute, no? Pwede ko na-copy ako ni siya, no? Calculate this one, no? Copy. Okay na. Okay. No? So, this one, butahan ko na siya unit, no? So, actually, this is actually 600. By the way, this is actually MPA na siya. Okay. So, yan, 347.6. Again, this is less than atong FY kanina. Okay. Oh, yan. So, okay na ni siya, no? So, this time, ang second solution natin, we assume that our C is less than, ang atong FS is less than FY. Since we did not solve for A, instead we use for C, no? Using this formula nga, ang actual value, no? So, okay na siya. No? Acceptable na ni, therefore, we can accept nga ang atong FS is equivalent to. Yan. So, this is already the actual. This is now the actual still stress, no? Okay. So, this is now the answer para sa atong first question, no? Ito na yun, no? So, answer ni compute the actual tensile stress in the reinforcing bars. This is the correct answer. Ito na yun. Dili kini siya, no? Okay? This is the correct answer. Okay. So, medyo tedious siya actually kung pag wala nag-yield ng atong steel, medyo tedious siya. Kaya you have to resort to quadratic equation. But in my case, no, since I'm using the software, okay, so I don't need to show you how to perform quadratic equation. Okay, I'm assuming that you already know how to determine how to perform quadratic equation. No, okay, algebra pa man na. So I'm assuming that you already know that. Instead, I'm showing you how this program. Okay, this is very handy. No, if you are actually work, no, much better if you use the program. So you can use this program kung namo computer no to answer your assignment. No, I highly encourage, in fact, I highly encourage use the program. But kung wala naman kay computer, wala naman, then pwede gyapon tag manual. No? Okay, so this is the actual stress. So next natin, total compressive force. May kasi ang capital C. No? So, since natin actual stress, so we have na the total compressive force. So, ang C natin, we have the formula C is equals to 0.5 times FC prime times A, no? 0.5 times FC prime times A times B, no? Compute sa A, no? Since we have your C, A equals to beta 1 times C. Okay. So, beta 1 being 0.5. Ayan. So, nata, no? Okay, pa kung yung beta 1 na rin. 0.5. So, pinag pa rin eh. Finally, no? So, ini. Pwede ka muna lang mag-ansaraan eh. Kumulang okay, so mali nga itong C. This is the compressive force C. No? Ito yung answer sa next. Okay. Okay, so mali answer dire. Total compressive force acting on the section C. Okay. Pwede po yung calculate ng T, no? Ang T, ang tension nila ni equivalent to, pwede po yung calculate AS times FS. No? As you can see, similar sila, no? Parehas. Decimal siya maglalis. Okay, finally, nominal moment strength. Design moment strength. Okay. Design moment strength. Again, for one layer, hindi ko matanga, for one layer, since i-assume natin na single layer ni siya, Then, ang atong then it's obvious nga this is compression control. Therefore, this is compression. So, pag compression control, therefore, ang atong reduction factor for compression control is 0.65. Okay, 0.65. So, design moment strength, pagkikita. So, atong MN. So, since kinumpute na matong si C, pwede natin C times the quantity B minus A over 2. Okay? In C. Okay, so the Newton meter. And finally, design moment strength, that would be P times yan. This is the answer. No? Patingnan ko, katong formula ito kanina, pwede pa ito gamitin, pwede gapon. Pwede ka mo-compute kayo na, let's say, no? MN, let's say, wala MN to lang, no? Para, pwede ito gamitin kayo na AS, but take note, dili ka mo gamit ang FY, but instead, you will use FS na. Times P minus A. Okay, kasi kasi parehas, no? So, ang atong gamitin diri, pwede gapon kini siya, but take note ha, since wala nag-yield na ato steel, dili FY yung mga gamiton, FS. But kung nag-yield na mo steel, FY. But in this case sa ato, no? Since wala nag-yield na atong steel, no? Steel na sa yield, yung gagamitan mo is FS. So, pwede gapon kini, you can have the same, the same answer, no? Okay, so that is the answer, no? Yan, no? This is how you analyze beam, no? So, kining example, this is for compression control, no? It's actually for compression control yung problem. Nakakadali, no? So this example is for compression control. Okay. This is compression control. So, kailangan mo na lang yung compression control. Okay, so this is how you approach pag compression control, yung problem. Well, ang kanina na akong example is, ang first na ako is tension control. Ang second example natin is transition region, no? Okay na to. So, kaya na ito example kanina, this example, problem 2. So, kinisiya, this is actually transition region. Okay, tapos ang rin. An example is for the transition region. Example 2. So, then ang akong next sample, ang example na akong kanina, ang first na akong example, the very first example, we have tension control. Okay, yan. No? So that is how we analyze your beam. No? Okay, so now you know how to analyze a beam. But again, analysis is different from design. So in analysis, we are given with the sections, the dimensions, no? The rebar, the strength, and then we are to determine the ultimate moment capacity. No? While if you are to design, what you are given with the moments, and then you are required to determine the dimensions and the state reinforcement. No? So the opposite process of analysis is design. Kapit na. Okay, so that is how we, so next meeting we're going to learn how to design a beam. No? Okay, so if you have no more questions, no, so kung wala may questions, so palihog na lang to, type your name in the message, no, para sa attendance. Sige, so I have to go, no, kay I have an urgent activity, no, so if you have questions, kay email na lang sa ako, no, so paki-type lang diri ang atong name, no, for the